So if I want to find the area of a non-right angled triangle, okay, I can use this formula here. It says that the area is equal to a half of lowercase a times lowercase b times the sine of capital C. Okay, and to understand this formula, we first need to understand what these little letters here are actually referring to. So when we have a non-right angled triangle, maybe it's this triangle here. Our lowercase a, b, and c, these guys are referring to our sides. And our uppercase a, b, and c, these guys are referring to our angles. So for example, let's label our sides first. So our sides can be in any order. We'll say this one's A, this one's B, and this one's C. However, the angles, they have to go directly opposite our sides. So if this is our side A, then our angle capital A will be this angle down here. And if this is side B, then our angle capital B has to be this one down here. And of course, if this is then side C, then our angle capital C has to be that one up there. Okay, so you can see that the angles correspond directly opposite to their respective sides. And if we have a look at why this is written as lowercase a and b and a capital C, what's going on there? Well, you can see clearly that if I select lowercase a and lowercase b, then my angle uppercase C is that angle that is enclosed between those two sides. Okay, so lowercase a and lowercase b, this part is basically just saying any two sides. Okay, so just any two sides. But the capital C part, that's saying the angle that is enclosed between them. Okay, so for example, if I have a non-right angled triangle out here, and I have this side and I have this side, I would need this angle to be able to calculate the area. Okay, if I had a non-right angled triangle and I knew this side and I knew this side and I had this angle here, then that wouldn't be of much use to me because I need the enclosed angle between those two sides. So hopefully that makes sense about how we label our non-right angled triangles with this lowercase a, b, and c and our uppercase a, b, and c, and just why they've selected this lowercase a and b and this capital C here, because we're talking about any two sides and that enclosed angle. If we have a go at an example now, so we know that the area of a non-right angled triangle is given by a half of the two sides multiplied together, multiplied by the sine of the angle enclosed between them. Okay, that's what that A, B, and C means, remember. So let's say that our non-right angled triangle looks something like this here. And we'll say that this is 4 centimeters and this is 7 centimeters, and this angle that's enclosed between them here is 80 degrees. And we need to try and find the area of this non-right angled triangle. Well, the area is equal to a half times my two sides, so my 4 and my 7, multiplied by the sine of the angle that is enclosed between them, which in this case is 80 degrees. And if you were to put this into a calculator, you would get about 13.8, and we're in square centimeters here for area. If we were to do perhaps another example, maybe we're up here, something like this, and we've got, again, let's say we've got 4 centimeters here, but maybe 10 centimeters down here, and we know that this angle in here is 45 degrees. Well, then again, we just use the formula. The area is equal to a half times 4 times 10, because they're my two sides, times the sine of the angle that is enclosed between them. Okay, and again, if you pop that into a calculator, you will get about 14.1, and we are in square centimeters again here. If we take a look at a couple more examples, let's remember again that the area is equal to a half times AB times sine of capital C. Okay, so let's say that our non-right angled triangle looks something like this one here, where we've got an unknown side length x. Here we're told that this one up here is maybe 8 meters long, up there, and then this angle in here, perhaps that one's 30 degrees. However, we're told here that the area is actually equal to 12 square meters. So how might we work out what this unknown side length x is? Well, if we put what we know into this formula, so we know that the area is 12, we know that that is equal to a half times our two side lengths, so that's our 8 and our x, multiplied by the sine of our angle, which is 30 degrees. So now if I want to rearrange this equation, I can bring this 2 up. So I do a multiplication there, and this 8 and this sine of 30 will be a division. And you can convince yourself that when I rearrange this, I get to 12 times 2 over 8 times the sine of 30 degrees. Okay, and if you pop that into a calculator, you should see that x is about 6 meters long. Okay, so x is approximately 6 meters long in that case. We'll do another example down here. Maybe we've got this this non-right angled triangle here. Maybe it's this one, and this is our angle theta, and this is 40 centimeters, and this side length here is 15 centimeters. And we're told that the area of this non-right angled triangle is 103 centimeters squared. So using our formula, the area is equal to a half times A times B times the sine of that capital angle C, that angle enclosed between them. And let's put in what we know. Well, we know that the area is 103. We know that that is equal to a half times my two sides, so my 15 times my 40 times the sine of that angle, which I'm not quite sure of. That's what I'm trying to find. That's my theta there. Now, again, you can convince yourself that when I rearrange this equation, I get 103 times 2 divided by 15 times 40, and that there is equal to the sine of theta. So if I want to try and isolate that theta term, then theta is going to be sine to the minus 1 of whatever that stuff is, 103 times 2 divided by 15 times 40. Okay, and you should see there that theta in this case is equal to about 20 degrees. So that's how we can use this formula here to calculate the area and sometimes the unknown side lengths and the unknown angles of non-right angled triangles.